In this video, I'm going to review page 1 and page 2 with you. So there are just a few new words here that we didn't see in class. Pre-image and image. So pre-image is the original figure. And the image is the figure after a transformation has occurred. Any transformation, whether that be a translation, reflection, rotation, or dilation. The first question, we're supposed to tell whether the transformation appears to be a rigid motion in isometry. I gave you this vocab word in class. Remember what it means? That size and shape is preserved. In number 1, it does look like the size has remained the same. And we want to tell whether it's a rigid motion. We say yes, it's a rigid motion because a reflection has occurred. And with a reflection, distance is preserved. The shape is preserved. And reflection happens to be one of the transformations that we say is an isometry or is a rigid motion because it preserves distance and shape. Now, in terms of distance, I'm talking about the lengths of the sides. So if this happens to be 2, even though it's been reflected, this side will remain as 2. Now in this figure, it looks like it has shrunk down from the pre-image, from the original to the new image. One thing you want to know is that if this is labeled as A, B, C, and D, the image will have the same letter, but a little apostrophe, which we read as A prime. So A prime is the image of A, B prime is the image of B, C prime is the image of C, and D prime is the image of D. So we read it as D prime, but the symbolic notation, it looks like a little apostrophe. In our second example, we see that it's become smaller. This quadrilateral becomes smaller, so we say it is not an isometry. The transformation that has occurred looks like it's a dilation, and with this type of transformation, let me put this here as a transformation. A dilation, it didn't change the shape, however, it changes the size. So we say no because the size has changed. It became smaller or it shrunk. So when you're explaining, it does say to explain, you can get into what type of transformation it is. This question did not ask us to specify. The question was asking us to explain why it's a rigid motion or why it's not a rigid motion. So we want to make sure in our explanation we're specifically stating that the distance and was preserved versus no, the distance was not preserved, or in other words, the size changed. On number 3, here's a question where it says specifically identify the type of transformation. And it looks like it's a rotation. If you notice the order of the letters as you go from starting with F going in a clockwise direction, it reads as F, H, and then G. And if you start off with F prime and also go in a clockwise direction, if you notice it goes F prime, H, and then G prime. If you notice there's no H prime because H and H prime happen to be the same point. It looks like it's been rotated through that point. Notice that the order of the letters did not change. It simply looks like this triangle has turned or rotated. So we'll identify this as a rotation through point H because point H is fixed. And we are asked for the second question. It says, what is the image of segment FG? Now you simply cannot just write F prime, G prime. You want to either put a segment on top or write the word segment f prime g prime. So remember, the image is the figure after the transformation. So if we look at our diagram, the original, this is the pre-image, and f prime g prime is the image. So pay special attention to whether you're working with a segment. You either use the symbolic notation or you write the word segment before f prime g prime. So for number 4, what is the type of transformation? We can see this quadrilateral. Here's the original, and the prime indicates that's the image after the transformation has occurred. We see that it has shrunk. We can see a dilation. All of the points changed except for point I. So it's a dilation with respect to I. Second part of this question, what is the image of angle J? If I just wrote J prime, that would be incorrect because J prime is just a point. Notice what word they put here. They wrote angle, so you must put an angle symbol, or you must write the word angle and then J prime. So J prime alone would not work as a response or would not be a correct response. Make sure the symbol or the word is there. And on to the last problems. We saw this in class. I'm just redoing this problem. We're looking for the image of 8. So the image is what comes after. So in terms of x and y, what came first is the pre-image. And then y is representing our image. So in question 1a, we're asked for the image. In other words, we're looking for the y value or the output. We can also look at it as an output. The pre-image is our input, okay? So if we're looking for the output, we'll say, well, this is 8. And to find the output, we just simply plug 8 into the function that has been given. And 24 plus 2 is 26. So our response would be 26. 1b asks us to find the pre-image when they've given us negative 1 as an output. So what you can do with this function, it's been given to us in this notation. You can always rewrite it as y equals 3x plus 2. This might make more sense to you because then you say, oh, they've given me the y value. So I'll just substitute that for y, and then I'll just solve for x, which means isolate x here. We'll subtract 2 from both sides, and then we'll get negative 3 equals 3x, and divide by 3 to isolate x. And finally, x, or the input value, or the pre-image, if we want to call it that now, is negative 1. So if you're dealing with equations, it's really not that bad. You just need to understand which one is your input, output. It's your pre-image and your image, your x and y values. And the last question I wanted to go over, which I did not get a chance to go over in class, is number 6. So you're given a rule here. T stands for transformation. And we want to find out what happens to A prime. So A is the pre-image, and A is the image. And so they're telling us that the x value is going to stay the same. So this is going to stay or remain as negative 4. What do they want us to do to the y value? They want us to add 7. So 9 plus 7 is 16. So that's the answer for A prime. The second part of this can be a little bit more challenging because we're going backwards. I gave you the image, and you want to go back and find the pre-image. Now, for the first part of this, it's pretty easy because x stayed the same. So 5, you can backtrack and say, all right, it was 5. But for 7, to get to 0, you had to add 7 to y. So to go backwards, you're going to do the opposite operation and say minus 7. So 0 minus 7 is negative 7. Your other option is to take y plus 7 and set it equal to that 0 and then solve. And that's another way to get negative 7. So if the problems tend to be very confusing and you're working backwards, set it up like this and it will simplify the problem for you. If you have any questions, just email me.